Okay, so we're starting our organic chemistry basically with looking at the overall reaction scheme of the chemicals we need to know. Having met the hydrocarbons, the polymers made from hydrocarbons, haloalkanes and alcohols have been met before, so they are nothing new. Some of the reactions with them might be though, and then we hit all the things we're making alcohols and making carboxylic acids. That is all new for this year. So this is the stuff that's really going to have to be learned. This stuff's going to have to be remembered and fine-tuned from last year. There's a bit of work to do there. What we want to do very quickly though is look at the types of reactions that are used to go from one type of compound to another. And what I've done in there is I've used 3 carbon examples of these. I haven't used 2 because it doesn't show the difference between ketones and aldehydes, for example, and primary and secondary alcohols, for example, if I only use 2 carbons. So I've gone for 3. 4 would have been better, but I would have run out of space on my whiteboard. You'll notice there's not 3 here, there's 6. There's a reason for that. These are made by putting 2 different organic compounds together. So we've gone from 3 to 6. So that's sort of to show you that they are what we call addition type reactions. You're adding one thing to another. That's not actually the term we use here. I'm going to start at the hydrocarbons because we've met them before. And I'm going to start with alkenes because it's got so many arrows attached to it. So we can look at the types of reactions that we've got. Now, to go from an alkene to an addition polymer, the name is given away in what it's making. The alkene in this case is acting as a monomer or single unit, making a polymer. So if you're just adding a lot of units together, it's just called a polymerization reaction. And in this case, it's addition polymerization. That's going to be more pedantic about it. So polymerization, probably the easiest one. So when you see the word polymer somewhere, it's probably going to be polymerization as it is. If you look at going from alkenes to alkanes, this is C3H6 and this is C3H8. What's being added is hydrogen. So it's being added, it's an addition reaction as well. But it's a specific type of addition reaction, this one, called a hydrogenation. Hydrogenation. I'm being very careful on saying that way because there's a very similar one where we could go, and I haven't put the arrows in which I'll have to, between alkene and alcohol. Okay, and in this one, we're adding H2O. So this isn't hydrogenation. Water is hydration. It's like when you add water to your food or whatever to it's hydration. So the opposite, not surprisingly, is a type of elimination reaction called dehydration. I'll put the word elimination there as an example of elimination. Here, we're taking out an H to put in an X. X can be fluorine, chlorine, bromine or iodine. Generally though, this year it will be chlorine. Alright? Apart from using bromine as a test for alkenes and alkanes, and it would be BR. So, here we're taking one out to put one in. And if you think of a sports analogy there, when you take a player off to put another one in, it's called substitution. That's exactly what this is called. Substitution. But from the alkene to the haloalkane, you're just adding. So again, it's an example of an addition reaction here. I'm not going to write that on again, so we've got the word up here. Here, we're taking X, so let's say chlorine, off and putting NH2 in its place. Taking something off, put something in is substitution. So that's the ones that we sort of met before. Then we get some really cool ones, okay? I'm not going to go to the amides just yet, I'll come to them later. We go back to our alkynes, alcohols, and look at what they become. A whole lot of things. In this one here, and this one here, 2 hydrogens are being removed. Now, because 2 H pluses are being removed, that's effectively what it is. It's what we call an oxidation reaction. Okay, so both of these, and actually this one here, are called oxidation. And really, it's a hard one to sort of give you any rules for. If oxygen is added, not H2O, but if just oxygen is added, that's oxidation. But it's also H's are being removed. It's the special ones, and we're just going to have to learn those. Okay? So alcohols can undergo substitutions, dehydrations, or a type of elimination. But the other one that they undergo is oxidation. Here. Here and here. And so you'll often put O with square brackets around it rather than writing the whole word. This one here, again, is really simple once you know it. It's making an ester, so it's called esterification. Okay? Now it's got another word. When you do this, water is released. Okay, not eliminated like a dehydration. It's not eliminated. It's released. So because it's released, then we call it condensation. In doing this reaction, we make water. So it's called condensation. It's also, if you want to think of it, it's taking two big molecules and condensing them up into one that's a bit smaller. Okay? So it's also an example of condensation. So therefore, polyesters are called condensation polymers. Alright? Carrying on up the top, amines to amides, you'll notice that that's also making a bigger molecule. Okay, but actually what we started with was an amine and a carboxylic acid. So again, this is called a condensation reaction. Either HCl or H2O will be liberated in this happens. So that's also a condensation reaction. So polyamides are another example of condensation polymers. Okay, so not many left. In here we are replacing an OH for Cl, taking something out, putting something in, substitution. So we don't have to write that. It's a special one called chlorination. Not a surprise, you're adding chlorine. Whenever you see chlorination, don't say that it's HCl being added, please. That is the biggest error that students make. PCl5, PCl3, or SOCl2. So phosphorus trichloride, phosphorus pentachloride, or thionyl chloride. You can also sometimes, but not in that particular case, use zinc and hydrogen chloride dissolved in concentrated hydrochloric acid. It gives you lots and lots of chlorine. Not so good on that one. Easiest one to remember is the phosphorus-based one. So chlorination, be careful with that. Now, there's only one really major one left. This, by the way, carboxylic acid to carboxylate ion is just whenever you have that acting as an acid. So reacting with the metal or the base. The last ones I've got are when you can see these big things being broken up into smaller things. Okay, esters being broken up into acids, or the carboxylate ions, or back into alcohols, for example. Okay. And these ones here are where you use an acid or a base dissolved in water to break them. So to break something in organic chemistry and also in biology is called lysis. So when a cell undergoes lysis, it bursts, it breaks. So if we're going to break our compound using something dissolved in water, it's called hydrolysis, hydrolysis. So when I break my amides or polyamides, it's called hydrolysis. And it could be acid hydrolysis, or it could be alkaline or base hydrolysis. Same thing when I break my esters or polyesters, that's also called hydrolysis. So there's a lot of types of equations to learn. There's this big picture we have to learn. So what we're going to do in the course of this topic is break those down into little bites that you can understand.